Hi everybody, so today we are going to be going through different techniques about the polar graph. So first of all, let's look at the question. R equal theta minus sine 3 theta on the interval from pi over 2 to pi. And we can see this is basically the graph, and regarding why this is pi from pi over 2 to pi, if you still don't know that, you should probably study your if you still don't know that, you should study your unit circle, right? That's why I was thinking about the unit circle. Okay, so first of all, we want to figure out what's the area under the curve of shaded region. So basically, we want to find the area A under this shaded curve. So first of all, we need to know the equation. Area under the curve for parametric is that A area equal 1/2 integral from the lower bound, which is pi over 2, to the upper bound, which is pi. And that's the area for the shaded region. And integral of r squared, in this case, r equal pi minus sine 3 theta. So we square this whole thing, d theta. Okay. Now it's the time to let our calculator do the work. So first of all, we want to make sure it's in the polar mode. Polar. Oh, sorry. Y-axis. Well, notice I always leave this here because sometimes we just have to use the differential equation of the R equation, and you will see that later. Usually I don't clear out this part, just leave it, which saves us some time. Well, anyway, let's get back to the problem. So we know R equal theta minus sine 3 theta. So, okay, this is what we have so far, and we don't actually have to graph it. We go straight to the integral, math 9 integral, vars, y vars, polar, and R1. Remember to square it because we are talking about R squared in order to find out the area under the curve. So parenthesis theta, because we are on a polar curve, from pi over 2, okay, pi over 2 to pi. So now we have the lower bound, upper bound, and the appropriate equation. So let's do our calculation. Notice this is 7.512, and we are actually not done yet because we haven't really do the 1/2 part here. So we just use this number divided by 2. And that's our answer for the area under the curve, which is 3.5756. We don't need to round it up because the next digit is a 1. Okay, so let's look into our next question. We want to find out what's the arc length of the curve shown above. So the arc length of this curve. So this time the arc length for the polar curve is kind of little different from the arc length for the parametric curve, but trust me, this is much easier. So AC, usually the general equation for arc length is AC equal integral the lower bound to upper bound r squared plus dr d theta squared d theta. In this case, it will be equal to integral from pi over 2 to pi. So we know, since we have the r squared and dr d theta squared in our calculator, then we don't really have to write it out. We just let the calculator do all the work for us, d theta. So See, we have r squared and we have the dr d theta square. Sorry, I mean this is dr d theta, and soon you will see how this is really useful to just leave it here. Let me close the parenthesis here. Okay. So we're gonna do the integral r squared, which we leave it as 3 polar and r1. We square it plus y polar r3, and we also square it. So this is basically the r squared plus dr d theta squared, and comma with respect to theta. From the on the interval, lower bound is the lower bound is pi over 2, and our upper bound is just pi. So now let's do the calculation. Boom. So this is what we should be getting for our arc length, which is 14.15. Well, since this is a 6, we're gonna round it up to 2. Okie dokie. And that's our arc length. And now we want to find out the slope of the curve shown above. When the theta is 3 pi over 4, which is talking about when the theta is somewhere here. 3 pi over 4 should be right in the middle between pi over 2 and pi on a polar scale. But in order to find the slope, that means we are trying to find out what's the dy dx. That means we would need dy d theta over dx d theta. Well, it's the same theory with the slope of parametric. Well, at least it's similar. So dy dt divided by dy d theta divided by dx d theta, which will be dy d theta times dx here, d theta divided by dx. So we can cross out d theta. That's how we get dy dx. But notice we are given r. We are not given anything about x and y. So here's what we're going to do. We know x is equal to cosine theta times r. In this case, will be cosine theta times the pi minus sine 3 theta. Oh, why didn't I write sine? It's weird. Sine 3 theta. And y squared equals sine theta times r. In this case, will be sine theta times theta minus sine 3 theta. Okay. So what we're gonna do is that we're gonna type this into the calculator. In this time, we are going to actually use the parametric mode, since it kind of makes more sense to me, at least. So cosine t, well, it doesn't matter it's theta or t, it's actually doing the same work. And t minus sine 3t. This is sine t. What am I pressing here? Sine t minus sine t times t minus sine 3t. Okay, so this is what we have so far, and here's what we want to know. We want to know the dx d theta when t is equal to 3. I mean when theta is equal to 3 pi over 4. And we want to know what's a dy d theta when theta is equal to 3 pi over 4. What we're going to do is we're going to differentiate the x and y equation, which doesn't have to be done on paper. We can just do that with our calculator. See, I already set it up earlier. I never deleted it, so it's always here. We close the x1t and y1t. In order to get an appropriate table, we actually have to go to the second window and change something. We want a table to start at x, but we want a scale to be pi over 4. Because otherwise we wouldn't be able to find pi over 4 since it's not really a whole number. So now we can go back to the y equal. So we have what's the dy, we have the dx d theta, we have the dy d theta. We go to the table. This will be pi over 4. This will be 2 pi over 4, which is basically pi over 2. And this will be the 3 pi over 4. So the dx d theta value at 3 pi over 4, that is negative 0.373. And the dy d theta value as pi equals 3 pi over theta equals 3 pi over 2 is negative 1.959. So since we have the dx d theta and dy d theta as 3 pi over 4, we can go back here. Dy dx at pi theta equals 3 pi over 4 is equal to dy d theta, which is negative 1.959 divided by dx d theta, which is basically negative 0.373. And we will let the calculator do the work. We quit the table. Negative 1.959 divided by negative 0.373. Well, you actually don't have to enter both negative on calculator since you already know they will cancel out. It will be a positive number. And the answer we get here is 5.252. So this is our slope at theta equals 3 pi over 4. And that's all about polar. Thank you for watching.